When we're rationalising the denominator, we use the fact that a third squared gives the number under the radical sign. So to do this for 1 over root 7, we take the irrational part that's on the denominator and we multiply by root 7 over root 7 in this case, because the irrational part in the denominator is root 7. This is the same as multiplying by 1 because root 7 over root 7 is equal to 1. So it doesn't change the value, it just allows us to express 1 over root 7 with a rational denominator. So 1 times root 7 gives me root 7, and root 7 times root 7 is the same as root 7 squared, and it comes out to be 7. So that's my final answer for question 1, part A. With part B, it's quite similar, but we have a 2 root 2 on the bottom. Now we can multiply the top and bottom by 2 root 2, but we really only need to take that irrational part. So if we multiply this by root 2 over root 2, on the top we get root 6. Root 3 times root 2 gives me root 6. On the bottom, two is our rational part, and that needs to be multiplied with root 2 squared. Root 2 times root 2 gives me 2. So tidying up on this last line here, we get root 6 over 4. That can't be simplified any further, so that's our final answer for 1 part B. We'll have a look at some slightly harder types. Now in 1 part E, this is where we really need to know about our difference of two squares rules. So if you have a binomial on the bottom, so two irrational expressions adding or subtracting, we take what we call the conjugate and we multiply by the conjugate over the conjugate. So the conjugate of root 3 plus root 2 is root 3 minus root 2. All we do is we take the opposite sign in the middle. And again, this is just the same as multiplying by 1, because root 3 minus root 2 over root 3 minus root 2 is just 1. Now I'm going to put this in brackets because you just need to remember that when I'm multiplying this 4 across, I'm multiplying by both those terms inside brackets. So this is how we do it. On the top, we're going to have 4 outside of root 3 minus root 2. On the bottom, this is a difference of two squares. So we've got root 3 plus root 2 times root 3 minus root 2. When we have a difference of two squares, we square the first term. So root 3 squared gives me 3. And then we subtract the second term squared. Root 2 squared gives me 2. Tidying this up, 4 times root 3 gives me 4 root 3. And 4 times negative root 2 gives me negative 4 root 2. 3 minus 2 on the bottom gives me 1. So it would be 4 root 3 minus 4 root 2 over 1. But as we should know, if anything's over 1, you don't need to write the denominator. Okay, a slightly harder one again. It's not quite as hard as it looks. We just need to remember our fraction rules for adding and subtracting. So in order to add these two fractions, I need a common denominator. So on this first one, I have a root 2 plus 1. I need a root 2 minus 1. So I'm going to multiply, cross multiply, root 2 minus 1. So I get on the top line 1 outside of root 2 minus 1. And then that means that on the bottom I have root 2 plus 1 times root 2 minus 1. Now I need to fix this second fraction. It also needs to have the same denominator as what I've just figured out there. So it has a root 2 minus 1. I need to multiply the top and the bottom by root 2 plus 1. So on the top line, there's a plus in the middle, so a plus goes in the middle there, and I get 1 outside of root 2 plus 1. Now we can do a bit of tidying up. On that top line, I expand those two sets of brackets. So 1 times root 2 gives me root 2. 1 times negative 1 gives me negative 1. Plus 1 times root 2 gives me root 2. And 1 times positive 1 gives me positive 1. On the bottom, I've got a difference of 2 squares. So I square the first term, and on root 2 squared gives me 2. And then I square the second term. 1 squared gives me 1. Remembering there will always be a minus in the middle for a difference of 2 squares. That's why we call it difference. Sorry, just get a little bit more page there so we can see a bit more of that. Okay, now on our final line, we just do some tidying up. So collecting like terms, root 2 plus root 2 gives me 2 root 2. I've also got a negative 1 that will combine with that positive 1 to give me 0, and 2 minus 1 gives me 1, so it's 2 root 2 over 1, which is just the same as 2 root 2. There are some more difficult ones in there as well, so just make sure you ask me if you need me to go through any of those other types.